So in this section, we'll be reviewing the difference between probability and odds. So first, I'd like to take you through a bunch of different types of probability. For example, you'll see a couple different pens on your screen. A green pen, a purple pen, another green pen, a red pen, and a pink pen. So there are 5 total. In probability, we always want to discuss the wants divided by the total number. So we have 5 pens in total. So if I want the probability of picking a pink, if I put these in a hat or something, there is 1 pink pen. There's 1 like that of what we want out of 5 total. If I wanted to pick the probability of blue, there are 0 blues in this set out of 5 total, which would reduce to 0. I like to call that a fat chance. You know, good luck doing it, because it's not going to happen. How about the probability of a color? Well, all of those are colors out of 5 total, and that reduces to 1. I like to call that a sure thing. Then you get to the and statements or the or statements. The best way of thinking about it is or in general is going to use a plus sign, and in general is going to use a times sign. And instead of doing ors where you have to worry about maybe having a duplicate criteria, like less than 5 or even, where you'd have to add and then take out the duplicates, the best way of doing it might just be to list out your sample space and pick the things that you want. For example, if I want to pick a green or a pink, there are 3 of the type that I want out of 5 total. So again, another way of doing it could have been there are 2 greens out of 5, or, which is really an and, 1 pink out of 5. And you'll notice that that's the same thing. Since there are no duplicate entries in this case, we wouldn't have to subtract anything. But again, if I said less than 5 or even, you would be double counting some things. Let's talk about the and statements now. With and statements, you're going to be talking about with and without replacement. Just remember, if you don't put it back, your totals are always going to get smaller. So the probability of picking a green is 2 out of 5. And let's say you pick one, has to be what you want in the first part, so we're picking a green, and you don't put it back, that's what it means by without replacement, then now your new total is 4. And when I look for what I want, there are now only 1 of what I want left. So 1/4 times 2/5. We multiply the top, we multiply the bottom, and we always reduce. So let's do that again with green and green, but with replacement. Green is 2/5. We take out that green one, but we put it back again. So the next time we do a green is also going to be 2/5. So multiplying that together, it's going to be 4/25. Whoops, I almost made that mistake there. And that does not reduce. If we take a look at green and pink without replacement, again, we're taking out that green. That would be 2/5. We don't put it back. So now with regard to the pink, there is 1 of the type that we wanted, but out of only 4 now, because we took that green one out, so the denominator is going to go down by 1. Multiplying across and reducing it, again, 1/10. If I look at green and pink with replacement, to start, green is going to be 2/5. I take the green out, but I put it right back in. And pink, that would be 1/5 for a final answer of 2/25 that does not reduce. Okay, now compare all of that to odds. In odds, we want to do the wants as compared to the not wants. So the odds of picking a pink would be that there's 1 pink and 4 non-pink. The odds of picking a green or a pink would be 3, like the type that we want, compared to 2 that we don't want. I want you to notice if you take the numbers that you use in odds and you add them together, you will always get the total of the number of items in your sample space. So whereas probability is wants over total, odds is wants as it compares to not wants. Good luck in the section.